and thank you for joining me. Welcome to the third session of AZ-900 Microsoft Azure Fundamentals. I hope you have had a chance to watch the previous videos in this series and are ready to continue building your Azure knowledge. I'm Alexandra Zakharova, Senior Technical Trainer and AI Course Lead at Microsoft, and I'm delighted to guide you through this part of your Azure journey. If you'd like to connect, you can find me on LinkedIn via aka.ms/Alexandra. In this session, we will focus on Azure management and governance. You will learn how to organize resources effectively using management groups and subscriptions. Explore compliance tools that help you meet regulatory requirements and understand cost management strategies to keep your cloud spending under control. We'll also cover monitoring and optimization services like Azure Monitor and Azure Advisor, which provide insights to improve performance, security, and reliability. By the end of this session, you will have a clear understanding of how to manage, govern, and optimize your Azure environment, skills that are essential for any cloud professional. So let's get started. In this we will shifting gears from core services to the tools and practices that help you manage, govern, and optimize your Azure environment. We'll start with cost management, exploring the pricing calculator and how tax can help you track and control spending. Then, we'll dive into governance and compliance, where we'll learn about blueprints, policies, resource logs, and the Service Trust Portal. Next, we'll look at resource deployment tools, from the Azure Portal to PowerShell, CLI, and even advanced options like Azure Arc and Azure Resource Manager. After that, we'll cover monitoring tools including Azure Advisor, Azure Service House, and Azure Monitor, so you can keep your environment healthy and efficient. By the end of the session, you will know how to manage costs, enforce governance, deploy resources effectively, and monitor your Azure environment like a pro. Ready? Let's get started. And let's start with a very important topic: how to manage your finance and maximize savings with Azure. The cost of Azure resources is influenced by several factors. Let's discuss 6 important factors. The first factor is the type of resource. When you provision an Azure resource, Azure creates metered instances for that resource. The meters track the resource's usage and generate a usage record that is used to calculate your bill. The second factor is consumption. As we mentioned in our first session, the pay-as-you-go model is a cloud payment approach where you're billed for the resources utilized during the billing cycle. If you consume more compute resources in the cycle, your payment will be higher. If your usage is lower in the current cycle, your payment will be reduced. It's a straightforward pricing mechanism that offers maximum flexibility, as we previously discussed. As mentioned earlier, you're only charged for what you actually use. This direct pricing mechanism provides maximum flexibility. However, Azure also allows you to continuously use a specific fixed amount of cloud resources and receive discounts on these reserved resources. Many services, including databases, compute resources, and storage, offer the ability to set a fixed level of usage and receive discounts. In some cases, discounts can reach up to 72%. When you reserve capacity, you define a fixed amount of Azure resource usage and payment for a specific period, usually 1 or 3 years. Using resource capacity allows significant saving when using stable and predictable workloads, while still having the flexibility to increase cloud resources as needed. The third factor is maintenance. The flexible capabilities of the cloud allow you to quickly adjust resources on demand. Monitoring in Azure helps you preserve financial resources by providing various recommendations. such as shutting down underutilized virtual machines. By tracking resources and not retaining resources that are no longer needed, you can effectively control cloud costs. The fourth factor that affects cost is geography and placement of your resources. When provisioning most resources in Azure, you need to specify the region where the resource will be deployed. Azure's infrastructure is distributed globally, allowing you to deploy services centrally or as close as possible to where your customers use them. Such global deployment results in global price differences. The cost of electricity, labor, taxes, and fees varies depending on the location. Due to such cost variations, the deployment cost of Azure resources may differ depending on the region. Network traffic, our fifth factor, also depends on geographical location. For example, data movement within Europe includes lower cost than data movement from Europe to Asia or South America. Billing zones are a factor that determines the cost of some Azure services. Bandwidth refers to data movement to and from Azure data centers. The fifth factor is network traffic. In some cases, inbound data transfer is provided at no cost. Charges for outbound data transfer depends on billing zones. And finally, the sixth factor is subscription. Some type of Azure subscriptions also include usage quotas that affect costs. For example, the free Azure trial subscription provides access to a range of Azure products for free for 12 months. It also includes credit for expenses during the first 30 days from the registration date. You get access to over 25 products that are always provided for free. Now that we have examined the dynamics of resources placement and network traffic costs, let's shift our focus to the Azure Marketplace, a platform that extends your Azure experience by offering solutions and services from third-party providers. This can include servers with pre-installed and configured software, devices with managed network firewalls, or connectors for third-party backup services. When you purchase products through the Azure Marketplace, you may pay not only for Azure services you use, but also for the third-party provider services. In this case, the billing structures are determined by the provider. All solutions available in the Azure Marketplace are certified and comply with Azure policies and standards. Certification policies may vary depending on the type of the service or solution, as well as the Azure service. Emerging from the Azure Marketplace's insight, let's now turn our focus to the Pricing Calculator, an invaluable tool in comprehending potential Azure expenditures. This calculator is freely available online and allows you to estimate the approximate hourly or monthly cost of using Azure. The Pricing Calculator is designed to provide an estimated cost of provisioning resources in Azure. You can pre-assess the cost of individual resources, build a solution, or use a sample scenario to view Azure cost estimates. The main focus of the Pricing Calculator is on the cost of provisioned resources in Azure. With the Pricing Calculator, you can evaluate the cost of all provisioned resources, including compute resources, storage, and associated networking expenses. You can even consider various storage options, such as storage type, access tier, and redundancy. To better understand how the Pricing Calculator works, let's take a look at it in the browser. In this demo, we'll explore together Pricing Calculator. It's available to everyone publicly. You can Bing it or Google it, or just copy-paste the link from Microsoft Learn, or type the same link that you see on my screen. And if you want to save your cost estimates, there I highly recommend to log in. It's not mandatory, just nice if you want to review all the scenarios that you reviewed in the past, you have this option. We do have all Azure products on the left side. You can select the products that you're interested in to discover their pricing. You have also some example scenarios to include in your estimates, and you have a third tab here to find your saved estimates if you log in into this platform. You can add a virtual machine to our estimate just to see how you can use this useful tool. We select a region for a resource. You'll see that it's modified directly the price on the top right corner. We can also select the operating system of our VM. For sure, if you switch from Windows to Linux, the price decreases significantly. We can select the type of our VM, the tier, so we'll change the price, the number of instances, the size of it, the powers, and you see that it's modifies the price for hour as well as a total monthly price. And if we want to, we can estimate as well the amount of VMs that we needed, amount of hours that we'll use them, and there are multiple savings options available to us. If you want to book it for 1 year or 3 years, it will provide you 24% or 45% account accordingly. It's why I always highly recommend to use those reservations plan if you're sure that you'll use this resource over a long period of time. If you bring your own hybrid benefits or your other licenses, also can be good saving options available to you. Let's try it on something different. For example, storage account. If you go to our storage account, we can again change the region from east to Sweden Central, and on the top right corner the price change. We can modify the type of storage account, performance, access tier will impact also our price, and redundancy option changing from LRS. For example, LRS it's $90. If I put something more interesting here like ZRS, it will increase the price to $68 per month. So it's kind of a big difference in the price of storage account due to its setup. You can also estimate operations and data transfer here for write and read, create operations. And after you set up all resources here that you're interested in by adding them to estimate, you can export it from the bottom part. But I highly recommend to review all those different options, especially if you really want to know how pricing is working in Azure. And when I mentioned that you can download it and export it, you have this export to Excel in the left bottom corner. So when I click on export, let's say because I don't want to log in and save it locally, but I would love to prefer to keep it on my laptop, I'll just switch currency to euro. As I'm based in France, it kind of makes sense to me. And I will download that Excel. It's pop up on a different screen. Let me bring it to this screen that I'm currently sharing with you. And I will find here everything that I set up with the service name, description, estimated monthly cost, and I will find total here. So it will help me to decide if I want to move with Azure, but also estimate my expenses thanks to this free pricing calculator available in public access to everyone. So don't hesitate to play with it. I really like this tool. Again, it's only estimate. It's not exact amount of money that you will pay. You have other resources for it in Azure, but it's a good resource to estimate better and decide if you want to move to cloud. Let's come back to our slides. The Cost Management service allows you to easily track the expenses of your Azure resources. You can set up alerts for costs and create budgets to manage your resources more efficiently. You can find it within the Billing and Resource Management section, or as a standalone tool designed for teams managing costs across different scopes. You can also automate tasks and add cost-related features to your tools and processes. This enhances visibility and accountability for your organization's goals. Cost management works in the Azure portal, Microsoft 365 Admin Center, or Power BI. It also sends various emails and alerts to help you stay informed and manage your account and cost effectively. Within the Azure Cost Management service, there is an additional feature called Cost Analysis. This gives you a visual overview of your Azure costs. You can see your total cost in different ways, such as billing cycles, regions, and resources. Cost analysis is helpful for studying and analyzing your organization's expenses. By looking at accumulated cost over time, you can identify trends and drivers, helping you understand your budget's impact. The more you use the cloud, the more important it becomes to maintain proper oversight. An effective organizational strategy helps you comprehend your cloud usage and manage costs. One approach to arranging related resources is by placing them in separate subscriptions. Resource groups are also useful for managing interconnected resources. Resource tags offer yet another way to organize resources. These tags supply additional information or metadata about resources. It's important to know that tags are not inherited. This means you can apply tags at one level without them automatically displaying at another level. This flexibility allows for customizable tag schemas that can adapt based on the level. Resource group, subscription, and etc. A resource tag consists of a name and a value, and each Azure resource can be assigned one or more tags. In this lesson, we'll delve into Azure governance and compliance. By the end of this lesson, you will be able to describe the purpose of Microsoft Purview, explain Azure policies and resource logs, and understand the role of the Service Trust portal. Let's begin with Microsoft Purview. Microsoft Purview is a family of data governance, risk, and compliance solutions that can help your organization govern, protect, and manage your entire data estate. It combines the former Azure Purview and Microsoft 365 compliance solutions and services together into a single brand. The Microsoft Purview helps you gain visibility into assets across your entire data estate and enables easy access to all your data, security, and risk solutions. Moreover, Microsoft Purview manages sensitive data across clouds, apps, and endpoints. It empowers your organization to govern, protect, and manage data in a new, comprehensive way. Microsoft Purview includes unified data governance solutions that help you manage data services across your on-premises, multi-cloud, and software-as-a-service estate. That includes Azure Storage Services, Power BI, databases like SQL or Hive, file services like Amazon S3, and many more. Access policies in Microsoft Purview enable you to manage access to different data systems across your entire data estate. Moving on to another vital component, we have Azure Policy. This service in Azure allows you to create and assign policies for resource control and auditing, as well as management. These policies ensure compliance with various resource configuration rules, ensuring adherence to corporate standards. Azure Policy enables you to define individual policies or set of related policies called initiatives. Azure Policy assesses resources and identify those that do not comply with the defined policies. It can also prevent the creation of non-compliant resources. Azure policies can be set at each level, allowing you to tailor policies to specific resources, resource groups, subscriptions, and etc. Additionally, Azure policies can be inherited. So when you set a policy at a higher level, it automatically applies to all child groups. For example, if you set an Azure policy at the resource group level, all resources created in that group will automatically receive the same policy. Now, let's delve into the concept of resource locks. These locks play a crucial role in preventing accidental deletion or modification of resources. Just as you might have accidentally deleted a document and regretted it, resource locks help you avoid such incident. Even with the role-based control policies in place, there is a risk that Azure with the appropriate access level may occasionally delete critical cloud resources. Resource locks prevent deletion or updates of resources depending on the type of a lock. Resource lock can be applied to individual resources, resource groups, or even entire subscriptions. They can also be inherited, meaning if you place a resource lock on a resource group, it applies to all resources in that group. There are two types of resource locks. One prevents user from deleting, while the other restricts user from modifying or deleting a resource. Delete lock means that authorized users can read and modify the resource, but they cannot delete it. Read only means that authorized user can read the resource but cannot delete or update it. To better understand resource locks, let's take a look at how they can be configured in the portal. In this demo, we'll see how to manage resource locks. For it, let's select, for example, a virtual machine that we created before together, and I will go to the settings on my resource and I will find the locks. Here, when I click on locks, I have a possibility on the top via plus button to add some locks. I'll provide the name of my lock. Let's call it not modify, and I will select that this is read-only lock. It means that now I can't modify anything on this VM. To prove it, let's try, for example, to delete this VM after we put a lock on it, and we'll have a message saying that this virtual machine can't be deleted. And if you look in the bottom part, there will be small information about the lock. And if you want to delete it, you'll need first to remove our lock. If you want also to modify this VM and add some disk to it, for example, I will provide a new disk. Again, it should give us an error message because it was a read-only lock. And again, we can't update the VM. Why? If you look on the bottom part, please remove the lock and try again. This is the purpose exactly of our read-only lock, so that we can't delete and we can't modify our resource. If you want now to modify or to delete, I will need first to delete this lock. As I can apply locks to the resources, I can also apply locks to the other levels like resource groups or even subscription, and the locks will be inherited. If I select locks on my resource group and let's call this lock not delete, and we'll just select a delete type of the lock this time, I will assign this lock to the full group. And now if I go to any resource inside of this group and I try to hit delete, confirming, okay, I want to delete, again, you will get an error message saying, please remove the lock and try again if you want to delete this resource. And this was only to illustrate that the locks are inherited to all resources in this resource group. And now if I want to delete something inside of this resource group, I would need again to delete first my locks. To summarize, locks are available on different levels. You can find them in the settings menu on the left side of your resource group or in the description, and it's an effective way to secure your data and resources. Let's come back now to our presentation. I hope you enjoyed the demo. Let's discover together the Microsoft Service Trust Portal. It provides various materials, tools, and other resources on how Microsoft Cloud Services protect your data, as well as how to manage cloud data security and compliance in your organization. The Service Trust Portal is a publicly accessible website by Microsoft Corporation to publish audit reports and other information related to compliance requirements concerning Microsoft Cloud services. The Service Trust Portal users can download audit reports created by external auditors and access analytical information from Microsoft technical documentation, which contains details on how Microsoft Cloud Services safeguard your data and manage cloud data security and compliance in your organization. To access some resources on the Service Trust Portal, authentication verified user need to sign in with their Microsoft Cloud Service account, review and accept the Microsoft Compliance Material Non-Disclosure Agreement. Additionally, on this portal you can use My Library. This feature helps you to add documents and resources, allowing you to access documents related to you in one place and receive notifications when they're updated. We are moving forward to the next lesson in this session. In this lesson, we'll get familiar with the features, tools for managing, and how to put Azure resources into action. We'll dig into what the Azure portal can do, explore Cloud Shell's capabilities, and understand how to use PowerShell and CLI. Additionally, we'll learn about Azure Resource Manager and cover Bicep, a useful tool for managing resources. You'll also discover Azure services that make handling both on-premises and multi-cloud setups easier. We'll look at Azure Arc too, a way to manage Azure's power beyond its usual reach, giving you more control and flexibility. To make the most of Azure capabilities, you will need a reliable way to interact with Azure environments, management groups, subscriptions, resource groups, resources, and etc. Azure provides a range of tools for environment management, including Azure Portal, Azure PowerShell, and Command Line Interface CLI. Now, let's explore how these tools integrate seamlessly with the Azure environment. The Azure Portal ensures resilience and constant availability with presence in each Azure data center. This configuration makes the Azure Portal resilient to individual data center failures and helps avoid network latency due to proximity to users. The Azure Portal is continuously updated and doesn't go offline for maintenance. Azure Cloud Shell is a browser-based shell that allows you to create, configure, and administer Azure resources using the shell. Azure Cloud Shell supports both Azure PowerShell and Azure CLI, which is the Bash shell. Azure Cloud Shell doesn't require local installation or setup. It authenticates using Azure credentials, so it already knows who you are and what permissions you have upon login. Azure PowerShell is a shell that enables developers, DevOps specialists, and IT professionals to execute commands called commandlets. These commands invoke the Azure REST API to perform management tasks in Azure. The Azure CLI has the same functionality as Azure PowerShell, but with commands written in Bash. Azure CLI provides the same benefits of handling discrete tasks or orchestrating complex operations with code. It can also be installed on Windows, Linux, and Mac platforms, as well as accessed via Azure Cloud Shell. Since Azure PowerShell and Azure CLI based on Bash offer similar capabilities and access procedures, I advise using the one you're most familiar with. And don't worry, for passing the AZ-900 exam, you don't need to know how to write these commands. Managing hybrid and multi-cloud environments can quickly become complex. Azure offers multiple tools for provisioning, configuring, and monitoring Azure resources. But what about on-premises resources in hybrid configuration or cloud resources in multi-cloud setups? Azure Arc allows extending Azure governance and monitoring to hybrid and multi-cloud configurations. The Azure Arc service simplifies management and administration by providing a unified management platform for multiple clouds and on-premises environments. Azure Arc enables projecting existing non-Azure and/or on-premises resources into Azure Resource Manager. This means you can manage virtual machines, Kubernetes clusters, and databases as if they were running in Azure. You can utilize familiar Azure management services and capabilities regardless of where the resources are located. Additionally, Azure Arc offers a cohesive experience by allowing you to view your Azure Arc-enabled resources uniformly. Whether you prefer the Azure Portal, the Azure CLI, Azure PowerShell, or Azure REST API, Azure Arc provides a unified approach to managing your diverse resources. This simplification enhances your operational efficiency and control across complex environments. Transitioning from the essential tools used to interact with Azure environments, let's now delve into the underlying structure that ensures seamless integration and consistent management. Azure Resource Manager, ARM, is a deployment and management service for Azure. It provides a level of control to create, update, and delete resources in your Azure account. Every time you perform any action with Azure resources, ARM is used. When a user submits a request from any Azure tool or API, it is redirected to ARM. ARM performs authentication and authorization checks on the request. It then forwards the request to the appropriate Azure service that takes the requested action. Since all requests are processed through a single API, results and capabilities remain consistent across different tools. The concept of infrastructure as a code in Azure transforms resource management by using code for provisioning and configuration. Infrastructure as a code involves defining infrastructure through code scripts, replacing manual setups. This consistency minimizes errors and ensures reproducibility. Infrastructure as a code fosters collaboration via version controls and shared scripts, promoting teamwork and consistent configuration. Scalability becomes effortless. Code-based replication avoids manual duplication complexities. Implementing infrastructure as a code means version controlling code, testing scripts, and using Azure's tool for verification. Infrastructure as a code empowers efficient Azure resource management through automation, consistency, and collaboration. Azure Resource Manager integrates seamlessly with infrastructure as a code through ARM templates, JSON files that define and deploy resources accurately. So ARM templates are an example of infrastructure as a code in action. With ARM templates, you can describe the resource you want to use in declarative JSON format. The ARM template deployment validates the deployment code before any execution, ensuring that resources are created and connected correctly. The template then manages the parallel creation of these resources. For instance, if you need 50 instances of the same resource, all 50 instances are created simultaneously. Developers, DevOps specialists, or IT professionals only need to define the desired state and configuration of each resource in the Azure Resource Manager template, and the template takes care of the rest. ARM templates can even run PowerShell and CLI scripts before or after resource configuration. They enable the declarative creation and deployment of the entire Azure infrastructure, including virtual machines, networking infrastructure, storage systems, and other necessary resources. You can write ARM templates two different ways, by using JSON and by using Bicep. Bicep uses a declarative syntax that you treat like application code. Treating your infrastructure as a code enables you to track changes to your infrastructure requirements and makes your deployment more consistent and repeatable. Bicep is intended to be easy to understand and straightforward to learn, regardless of your experience with other programming languages. All resource types, API versions, and properties are valid in Bicep templates. If you have previously looked into using JSON templates, you will notice that Bicep simplifies the template creation experience. It provides a simpler syntax for writing templates. You can reference parameters and variables directly without using complicated functions. You can reference the properties of a resource directly by using its symbolic name instead of complex reference statements. In most situations, Bicep automatically detects dependencies between your resources. This process removes some of the work involved in template authoring. You can see on this slide an example of how to deploy a storage account using Bicep. If we examine the JSON code, we will notice that the code required to deploy a storage account will be twice as long as the equivalent in Bicep. Let's take a look on my screen and we will see that it will take the 2 slides to reflect the same code in JSON. And finally, we move on to our last lesson in this session. We will discuss monitoring. Azure Advisor evaluates Azure resources and provides recommendations to enhance reliability, security, performance, efficiency, and cost saving. Azure Advisor was designed to save you time on cloud optimization. This recommendation service includes proposed actions that you can take immediately, defer, or dismiss. You can access recommendations through the Azure portal or via the API. Additionally, you can configure notifications to alert you about new recommendations becoming available. With a solid grasp of how Azure Advisor enhances resources management, let's pivot to another indispensable tool, Azure Service Health. Azure Service Health helps monitor your Azure resources, both individual deployed resources and overall Azure status. Azure Service Health achieves this through a combination of 3 different Azure services. First, Azure Status provides a broad view of Azure's global health status. It informs you about service outages in Azure through the Azure Status page. This page offers a global perspectives on the operational status of all Azure services across all Azure regions, making it a valuable guide for incidents with wide-ranging consequences. Secondly, Service Health offers a narrower view of services and Azure regions that you use. It's the best tool to find information about issues affecting the functionality of a services, plan maintenance, and optimization recommendation for your solutions. All of this is possible because the authenticated Service Health knows which services and resources you're currently using. You can even configure Service Health alerts to receive notifications about service issues, plan maintenance, and other changes that may impact your used Azure services and region. Thirdly, Resource Health is a specialized view of your actual Azure resources. This service provides information about the operational status of individual cloud resources, such as specific virtual machine instance. The combined force of Azure Service House and Azure Monitor enables you to set alerts that notify you of shifts in the availability of your cloud resources. Speaking of Azure Monitor, you might be wondering, what exactly is Azure Monitor? Azure Monitor is a platform for collecting data about resources, analyzing the data, visualizing information, and even taking actions based on the results. Azure Monitor can track Azure resources, on-premises resources, and even multi-cloud resources, such as virtual machines hosted by other cloud service providers. You can set up alerts to monitor logs and trigger specific logs event, or configure them to track metrics and trigger when certain values are crossed. For example, you can set up an alert based on metrics to notify when the CPU load on a virtual machine exceeds 80%. Alerts rule, based on metrics, provide near real-time notifications based on numerical values, while rules based on logs support complex data processing logic from multiple sources. Azure Monitor alerts use action groups to customize who needs to be notified and what action should be taken. An action group is simply a collection of notifications and action settings that you associate with one or more alerts. Action groups are used in Azure Monitor, Azure Service House, and Azure Advisor to send notification when alerts are triggered. With that, we conclude our third session of the AZ-900 Microsoft Azure Fundamentals course. In this session, you learn how to manage cost effectively using tools like the Azure Pricing Calculator and Resource Tags, enforce governance and compliance with policies and resource logs, and leverage the Service Trust Portal for transparency and compliance information. We explored resource deployment options, including the Azure Portal, PowerShell, CLI, Azure Arc, and Azure Resource Manager, giving you flexibility in how you manage your environment. Finally, we wrapped up with monitoring and optimization tools, Azure Advisor, Service House, and Azure Monitor to help you keep your Azure environment secure, reliable, and performing at its best. You are now equipped with the knowledge to control costs, maintain compliance, deploy resources effectively, and monitor your Azure environment like a pro. Your learning journey doesn't stop here. I encourage you to continue exploring other videos in this course or dive deeper into your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for joining me, and I hope to see you soon in our next learning adventure. Happy studying!